Okay, so last class we discussed about sample space and complements. So, what is a sample space? A sample space is the collection of all possible outcomes of a trial. So, a couple has one kid. So, what is the sample space for the gender of this kid? So, there could be two outcomes for this, right? So, one could be male or other could be female. So, the sample space is male female. So, if a couple has two kids, what is the sample space? Remember, in last class, we discussed that when a fair die is rolled twice, when we toss a coin twice, what is the sample space, right? So, it could be head, 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 tail, head, tail. And I taught you guys a shortcut, right? If you recall. So similarly, complementary events are two mutually exclusive events whose probabilities that add up to 1. So a couple has one kid. If you know that the kid is not a boy, then what is the gender of this kid? Then the sample space would be 1, right? Like only female. And boy and girl are complementary outcomes. So a couple has two kids. If we know that they are not both girls, then what are the possible gender combination for this kid? So out of these 4 sample spaces, we have to rule out the both girls one. So we only have 3, right? Yes. So independence. Two processes are independent if knowing the outcome of one provides no useful information about the outcome of the other. So knowing that the coin landed on a head on the first toss does not provide us any useful information for determining what the coin will land on the second toss, right? So we don't know. In the second toss it can be head or it can also be tail. Outcomes of two tosses of a coin are independent. Alright. So knowing that the first card drawn from a deck is an ace does provide useful information for determining the probability of drawing an ace in the second draw, right? So all of you guys have used or have played cards before. You know there are 4 aces, right? So if you see an ace in the first draw, then how many aces are left? 3, right? So we know the probability in the second draw that there would be only 3 aces left out of the 51 cards. So outcomes of 2 draws from a deck of cards without replacement are dependent. So let's look at a practice question. So survey interviewed 500 North Carolina residents, asking them whether they think widespread gun ownership protects law-abiding citizens from crime or makes society more dangerous. So 58% said it protects citizens, 67% of white respondents, 28% of black respondents, and 64% of Hispanic respondents shared this view. So which of the below is true? Okay. Ownership of gun ownership, opinion on gun ownership and race ethnicity are more likely what? Complementary, mutually exclusive, independent, or dependent? Or is it disjoint? What do you guys think? It's a dependent event, right? So if you are like, it depends. Like if the ethnicity is different, then gun ownership opinions are also different, right? They are not independent. Definitely they are not independent, right? And they are not complementary. Like if one is this, like let's say 100% is white, it doesn't mean 0% would be black. So they are not complementary events. Complementary are like boy, girl, or right sock, left sock, right? If you guys have done it in the economics class. Okay, so checking for independence. So if P A occurs given that P B is true, so we write it like this, like A given B equals to P equals to A. Then A and B are independent, right? So I will actually go over this in class. So protect citizens, everyone, common view is 0.58. This is the example of the last example, right? So if you can actually take a look, like probability of citizens, right, given white, that white is true, right, then it's 0.67. all right, so this is a product rule for independent events, right? So you toss a coin twice, what is the probability of getting two tails in a row? So first time it's half, in the second time it's again half, so getting two tails in a row is 1/4, okay, or 1/4. So let's look at the practice. If 25.5% Texans do not have health insurance, assuming uninsured rate stayed constant, what is the probability that two randomly selected Texans are both uninsured? 25.5% is 0.255. So if both are uninsured, it's like 0.255 square, right? Just like the tail example. See? So disjoint versus complementary. Do the sum of probabilities of two disjoint events always add up to 1? Not necessarily. There may be more than two events in the sample space. Right? Example is party affiliation. Do the sum of probabilities of two complementaries even always add up to 1? This is definitely. So when it's two complementary events like head and tail, the probability would always sum up to 1, right? But for disjoint, not necessarily, because some people have disjoint preference, like some people are supporting Republican and as well as Green Party, some people only supporting Democrat, some people Democrat Green Party, or something like that, right? Okay, so putting everything together, if we were to randomly select 5 Texans, what is the probability that at least one is uninsured? So if we were to randomly select 5 Texans, the sample space for the number of Texans who are uninsured would be, like, there are 5 options, right? So we are thinking that interested that at least one person is uninsured. So we can divide up the sample space into 2 categories. One is 0 and then at least one is uninsured, right? So the formula is, when P is at least one uninsured, we subtract 1 minus probability of non-insured. So probability of non-insured is 0.745 to the power 5. That means this is the probability, which is 0.23. So 1 minus 0.23 is 0.77. So at least one people is 1 minus probability of none. So this formula you guys have to remember. Okay, slide 26. This is the formula. If I said that at least 2 uninsured, then it would be what? 1 minus probability of at least what? At least 2 insured, right? So 1 minus, like, probability of at least 1 uninsured, right? So let's actually look at this example. I will get back to, like, slide 26 and 27. Roughly 20% of undergraduates at an university are vegetarian or vegan. What is the probability that among a random sample of 3 undergraduate, at least one is a vegetarian? So it's like 1 minus non-vegetarian, right? So 1 minus, what would it be? 0.8 cube. Yes, see, this is how you should do it. Okay, Now we will talk about conditional probability. So if you look at this example, researchers are randomly assigning like 72 chronic users of cocaine into three groups like decipramine, lithium, and placebo. So results of the study are summarized below. So relapse is 10 and no relapse is 14, right? For decipramine, lithium, and placebo, and all sum up to 24 and total is 72. So what is the probability that a patient is like relapsed, right? So here uh, out of total 72, 48 relapsed, so the probability the patient relapse is 48 over 72, right? And what is the probability that a patient received the antidepressant and relapsed? So when it's an and relapse, it's like a, you know, as I showed you guys in Venn diagram, is the common overlap area, right? So if I go to paint, okay, whenever it's and, so this common overlap area is the and part, right? It's always less. Like I said, I work in the econ department as well as I work at the Institute of Gerontology, right? So that chance is actually pretty low, right? So that's 10 over 72. And conditional probability of the outcome of interest A given condition B is calculated as this. A and B divided by probability of B. So this is the formula. Whenever we write PA over B, it's PA and B over PB, right? So let's do another example. Like I always like to use my own examples. So probability of, let's say, John John getting the dean's list. Okay, John given dean's list is John and dean's list divided by probability of dean's list. This is n, by the way, alright?